going to graph. Nothing's new with this, okay? First thing we do whenever we graph a line is we simply are going to graph 2 points. Then we're going to pause because we have to do something a little different than normal. So if you were to look at this right here, it's not an equation. How come it's not an equation? It's not. Thank you, Sherry. There's no equal sign. There's a different kind of sign. What kind of sign is that called? An inequality, right? So instead of being equations, we got inequalities. Looking at this and completely ignoring the sign, how could I graph a point? 2. What would I do with 2? So that's my y-intercept, so I'm going to place a 2 right there. They also gave me a slope. What's the slope? 1. So what would I do from my 2?
Go up 1.
And I could repeat that process a little bit, so I get a nice straight line. At this point is when we typically just draw our line, put our arrows on it, but we have to actually think about something before we do that. Notice we have a greater than sign. If you had the choice between this sign or this sign, one is solid and one is dashed. Which one do you think would be solid? The one with the solid line in it. So, in other words, we're saying we would draw a solid line in this scenario. Solid lines will use that type of inequality. But dashed lines are going to be the greater than or the less than. They won't be equal to, which means every single point on the dashed line, not a solution. Okay? So, based on that idea, would this be solid or dashed? Dash. So I kind of already got a dash thing going on, but I'm going to go ahead and do that. Put my arrows. Make sure you draw your line all the way across the grid because we're going to have to shade. Shade
above or below.
There's your question. So this is what I'd like for you to do. If I read this from left to right, how does it read? Oh, okay, good. Y is greater than. Take your pencil and put it on your line. Now I want you to use some common sense. Y is greater than. Do you think that's up or down?
Up.
Down. Okay.
So do we shade?
So where do you think you shade?
Up.
There you go.
Oh.
So therefore, if I want to shade above, I'm looking at greater than or greater than and equal to.
Then shade below is
there you go. I agree. We haven't done it yet, but yeah, shade below would be, of course, the opposite to. You ready to try another?
Yes.
Here we go. Is this in slope-intercept form?
No.
No, it's not. What form is it? Is it standard form or is that HK point slope form?
HK.
It's in HK, and if it's in HK, doesn't that mean we have a point hiding in there?
Yeah.
What is that point? Negative 2, 2. This is my H, this is my K, and my H is on the inside, so it's a lighter.
Yeah.
So you could plot this point, couldn't you?
No.
Sure you could. I have a slope. What's my slope? So what do I do from my point? Down 1 over 2, down 1 over 2, down 1 over 2. We could also go up 1, back 2, correct? As long as we go one of the directions as negative. Would this be solid or dashed? Dashed. What are you going to do whenever you accidentally make a line solid and it was supposed to be dashed?
Erase it.
Fix it.
What if you did it in pen or one of those non-erasable pencils?
You make X's on the line.
Just write a note. This should be dashed. Okay? If you accidentally draw a solid line and you can't erase it, then just put a note. This should be dashed. Just like sometimes when we accidentally connected the dots and it was supposed to be discrete, we just write a note. This is discrete. Shouldn't be connected. Same deal. Looking at this, I have y is less than. Put your pencil on your graph. Common sense, less than. Do you think that's up or down?
Down.
So where are you going to shade?
Below.
Pretty easy. Shade down.
That's what I heard in second period too.
Oh, really? That means they're wrong. That means it's not easy.
You try the third one.
Oh, jeez.
Oh, no, you don't. Hold on, we got a new thing there. This is still HK form, right? So there's a point hidden in it? What's the point?
2, 2.
2, 2. So I can plot that point, right?
Yes.
From that point, I can use my slope. What would I do with my slope?
Down
Down
1
1 over 2.
Down 1 over 2, down 1 over 2, up 1 back 2, up 1 back 2, up 1 back 2. Solid or dash?
Solid.
Very good. Solid, because there's the solid line underneath it. Put your arrows. Once again, put your pencil on it. Y is greater than. Where are you going to shade?
Up.
Good job.
Above.
Here we go. Looking at this is that last set. We did those standard equations where we use the hand. So we're going to keep using the hand. Looking at this first one, since it's in standard form, I'm going to cover it up and I get what? X equals,
4.
which means all I'm going to do is go to my x-axis and I'm going to plot 4, correct?
Yes.
Okay. This is at the bottom of your notes. Then I cover up my x because I'm looking for my y-intercept, and I got negative 2y equals 4, so y equals negative 2. And I put that on the y-axis. This is the y-intercept. Now I have to decide, is it solid or dash?
Solid.
Solid, so I'm going to draw a solid line, put arrows on it. Now that common sense moment of do you shade up or down doesn't work in this case because y is not by itself. Instead, we'll do a test point. I always want to do the easiest test point there is. What test point do you think that'd be?
0.
Very good. So if we did the test point 0, 0, that would mean for x I'm going to plug in 0, and for y I'm going to plug in 0. So I got 0 minus 2 times 0 is greater than or equal to 4. What happens to this side on the left? What does it become when you simplify it?
0.
0. Is 0 greater than or equal to 4?
No.
No, that's a false statement, correct? If it is a false statement, what it is telling you is that point 0, 0 is not a solution. And if it's not a solution, should it be in the shaded area?
No.
No, it means shade the other place. So we're going to instead shade.
Down.
Very good.
Yeah.
Now you could of course convert this to slope-intercept form, but that would take a whole lot longer than just plotting a test point, especially when you get to plot 0, 0, because that goes pretty fast. Ready to try the second one?
Yes.
So if I use the hand, I got 2x equals negative 4, so x equals, so I go to x and I plot negative 2. What's up?
I was explaining it to him, he didn't understand.
Oh, okay.
Re-explaining it.
We'll do a couple more, so stick with me. Then I've got what? I cover up my 2x and I got negative y equals negative 4, so what is y? I'm going to write that down just to help you out. Negative y equals negative 4, so y equals 4. 1, 2, 3, 4.
It's 8 dash.
2 points, solid or dash?
Dash.
Okay, so I'm going to draw my dash line. Once again, I don't have y by itself, so I can't use I'll put my pencil on it. Instead, I got to do a test point. What test point would you like to do? 0, 0. That's always the easiest. So I'd do 2 times 0 minus 0 is less than negative 4. What seems to continue to happen to this left side? It becomes what?
0.
Again, because it did a while ago, too. That makes it easy. 0 is less than negative 4. Is 0 less than negative 4? No, it is not. So if it's a false statement, that means this point right here is not a solution. So it should not be in the shaded area, so we should shade above.
Wow. This is easy against me.
You like that?
I really like this. Because I can understand.
Last one. X equals 6, so x equals?
6.
Yeah, that sounds like a trick question, doesn't it? So I'll plot that on the x-axis.
Well, that's probably
Yeah, don't plot on the y. Then I cover up my x, and I got 3y equals 6, so therefore y equals, well,
1/2.
Wait.
2.
What?
2.
1/2.
3y equals 6, therefore y equals 2. 6 divided by 3 is 2. Solid or dashed?
Dash.
Dashed.
Solid.
Once again, let's do a test point. What test point would you like to do?
1
0, 0.
So we'll do the test point 0, 0. Because it is the easiest, it doesn't mean it's the only one. The only thing you can't do is do a test point that's actually on the line. Other than that, you're good to go. So I got 0 plus 3 times 0 is less than 6. What happens to the left side? So I got 0 is less than 6. Is this true or false?
It's true.
It's true, which means this is a solution and should be in the shaded area.
Yes.
Which is down.
Which is down. Are you good with that?
Sure.
Take your piece of paper and flip it to the back.
Just back.
So in our shopping scenario, this is still that standard form. You remember in that last thing we had to write some standard form equations and they were a little different? It's okay, you don't have to make that face. I'm going to do it with you. A grandmother wants to spend no more than $80. Do you think Grandma's willing to spend $80?
Yes.
Will she,
Yes.
will she spend 100?
No.
Will she spend 40?
No.
Okay, so we're talking about 80 being a maximum amount or a minimum amount?
Maximum.
A maximum amount. So now I want you to picture your little, alligator.
Oh.
If I have my alligator face, is the minimum or minimum, which one is the minimum?
That's the minimum.
This side. So which one's the maximum then?
The right side.
So the alligator is actually eating or facing the maximum side. Do you agree?
Yes.
So when you look at this, was the $80 a maximum amount or a minimum?
Maximum.
So therefore, that is what the maximum would face. If 80 is the max, the alligator needs to face it.
Wait.
Is she willing to spend 80?
Yes.
So I need to add a...
Line.
That's the hardest part of writing these, is figuring out which way to face that inequality. After that, we've got pants. She's going to let me pee, and they sell for $20 each. That's kind of like the pigs had 4 legs each, right?
Yes.
So we got $20 pants, and what does P represent then?
Pants.
Number of pants.
Number of pants.
So I can go ahead and label my x-axis because the first one in a standard form equation is the independent, correct?
Correct.
Plus, well, if you got some pants, you better get some shirts too. So we got some $10 t-shirts. Keep in mind, if you use the variable t, you want it to be a little curved at the bottom so it doesn't look like a plus sign. I'll screen that. So my y is going to be number of shirts. I really have to get rid of this big old bold pen I got going on here. Using the hand, 20p equals 80, so p equals
40.
what? I'm going to do it again. 20p equals 80, so p equals
40.
4.
4.
I'll tell you what, if Grandma goes and buys you 40 pair of pants, I wouldn't want to have to carry all those bags.
No, thank you.
So we'll put 4 pairs of pants instead of 40. T-shirts. 10t equals 80, so...
8.
So in other words, if I don't buy any pants, I could buy 8 shirts. Solid or dash? Solid. Is this discrete or continuous information?
It is discrete.
It is discrete. You can't go buy half a pair of pants. And then again, I'm curious, what would you buy?
The shorts. So you get short shorts.
Those are called shorts, not pants.
What do you
They're not pants.
Short.
You can't argue that with me. They're not pants.
Short. Shorts.
We need to decide where to shade. How do we do that?
Shade.
We
The line, just like that. We're not
Well,
gonna use our notes.
above 80, go
Google.
left.
Yeah.
We can't do the above and
Use the
stuff
point.
because we don't have a variable by itself, so we have to do a test point. What test point would you like to do? So if we did test 0, 0, we would say 20 times 0 plus 10 times 0, which equals what?
0.
Is 0 less than or equal to 80?
Yeah.
Yes, so we would shade below. How come this is not an answer? You can't buy negative pants. Does that explain why I only shaded that triangular area?
Yeah.
Because our solutions really only fall within this triangle. I can't buy negative pants and I can't buy negative shirts.
Couldn't you just look at the inequality sign, and since it's like less than that, you can't do that?
Nope. Not unless the variable is by itself. That'll work in this sometimes, but it won't work all the time. So there's no foolproof to that at all. So figure out a solution for me.
What?
Tell me a solution from our graph.
0,
1, 1. That means what?
1.
I got one pair of pants and one shirt. There's more information to tell me. What is it?
That's below $80.
And it's less than $80. What's another solution?
2,
2, 2. I got 2 pairs of pants and 2 shirts and
Less than 8.
it's less than $80. Sometimes you might not have a pretty intercept, so you may need to change your inequality into intercept form. So let's practice that skill. We did it last time. If I had 20p plus 10t is less than or equal to 80, what would be my first step in getting it into slope-intercept form?
Get the.
Subtract 20p from both sides, leaving me with 10t is less than or equal to negative 20p plus 80. Now what would I do?
Divide by 10.
Divide by 10. Which would give me t is less than or equal to negative 2p plus 8. Is your y-intercept 8?
No.
Yes.
No. It's not.
Yes, it is.
8. Is your slope negative 2?
I'll have to check.
let me check.
Okay,
Yes.
check that. Yes,
Yes.
it is.
Over.
Did we shade below? Because this says t is less than. So our slope-intercept form matches? Yay, we did good. Let's try one more. Alfonso and Joan need to raise at least $300 to purchase new soccer jerseys. They need to raise at least $300. $300 is your max or min? Minimum, right? They'd be totally great if they'd be thrilled if they raised $4,000. But what they can't do is raise $250. They have to raise what? At least. Can they raise 300?
Yeah.
So, and that's our min, which means the minimum side needs to face. So now I've got what? $6 hamburgers plus $3 hot dogs. Do you agree?
Yes.
Using the hands, hamburgers equals 50.
50.
So this doesn't go out to 50. What will I do? We're going to go by 10s. Okay, so 10, 20, 30, 40, 50, 60, 70, 80, 90. Did I scale it by 10s?
Yeah.
Yeah, I just skipped every other one so it doesn't get all cluttered and stuff. So then I could go ahead and label 50, and while I'm here, how about I've labeled the x-axis as number of hamburgers so I do not forget. How many dogs? 100 dogs. Can I label by 10 still?
No.
Yes.
Yes.
So I got 10, 20, 30, 40, 50, 60, 70, 80, 90. There's my 100, and I can go ahead and label this number of dogs. Oh. Solid or dashed?
Solid.
Solid. Since I don't have a variable isolated, we're going to have to do a test point. What test point would you like to do? 0, 0. That would give me 6 times 0 plus 3 times 0 is greater than or equal to 300. Is 0 greater than or equal to 300?
No.
So therefore, the origin is not a solution, so where should we say?
Above.
Very good. Once again, would I shade below the x-axis?
No.
Why?
Because
You
it's
need
not negative.
300.
I cannot sell negative dogs. That doesn't even sound like a very good scenario. Give me a solution.
How would you sell it?
What?
50. 100.
50 and 100? Well, y'all are making some money. 50 and 100. So let's see. That means I sold 50 hamburgers and what?
100.
And 100 hot dogs. Finish it. What else do I have to put down? Because that's not enough
It
information.
is
300.
And it's what?
Over.
It's more than 300 and, or for more than 300. What could you tell me though instead of that? For more than 300, you could also have said,
Greater.
you could say it's greater than 300. Couldn't you also say, well, 50 times that, that's 300, right? That times that, that's 300. So I could say 50 hamburgers and 100 hot dogs and made $600. Wouldn't that be enough to say it as well? Okay. You have some individual